In this tutorial, we are going to learn about different types of hybridization. And also you will come across learning of some types of hybridized orbitals like sp, sp2, sp3, and dsp3, lastly d2sp3, as well as what we call effective pairs and effect of that on molecular geometry. Let's first summarize what we'll be learning in this tutorial. You will be learning the number of effective pairs, hybridization, and molecular geometry. What is hybridization? In order for atoms to react together, it was found that the orbitals of atoms sometimes get mixed together to form new orbitals. We call them molecular orbitals. And the name of the hybridized orbital depends mainly on the number of atomic orbitals that take part in hybridization process. So if one s orbital get mixed with one p orbital, they will result in two orbitals. We call them sp. Here we do have two effective pairs and the geometry of the molecule will be linear. However, if we have sp2, which will result from hybridization of one s and two p orbitals, of total of 3 orbitals, the molecular geometry will be trigonal planar. In tetrahedral geometry, the type of hybridization, we call it sp3. It results from mixing of one s orbital and 3 p orbitals, resulting in 4 orbitals. We call each of them sp3. In dsp3, one d orbital get hybridized with one s orbital and 3 p orbitals. So 1 plus 1 plus 3 equal 5. So we have total 5 effective pairs take part in hybridization. The molecular geometry here is trigonal bipyramidal. The last type of hybridization, we call it D2sp3. It does result from, you can guess it, D2 means 2 d orbitals, S means 1 s orbital, P3 means 3 p orbitals. So we have total of 6 orbitals take part in hybridization. So they will form 6 orbitals. Each of them is called D2sp3. The molecular geometry of this molecule will be octahedral. Hybridization means process at which atomic orbital mix to form new identical hybrid orbitals. We call them molecular orbitals. In case of methane molecule, carbon often undergoes hybridization and form 4 orbitals. Each of them is sp3, which is formed from one s orbital and 3 p orbitals get mixed. Remember that also lone pairs take part in hybridization and make hybrid orbitals. This is the structure of methane molecule. How the hybridization happened? Remember the structure of carbon atom, which is 1s2, 2s2, and 2p2. In order for hybridization to take place, one orbital of s get mixed with 3 p orbitals, resulting in 4 orbitals. Each of them is sp3. 1s, 2px1, 2px2, 2px3, resulting of total of 4 orbitals. Each of them is sp3. S orbital, as you know, is spherical in shape, while p orbitals, each of them is dumbbell shape. So when one s orbital get mixed with px and py and pz, they will result in total of 4 new orbitals. Each one has got this shape and we call it sp3. They are going to orient themselves in space in such a way, making the molecule as a whole tetrahedral, as you can see here, with a bond angle 1